Now we're going to look at functions algebraically and how to find the domain of these. Okay? So the domain of a function is all real numbers where the function is defined. There are instances when you're given a function, okay, like given an equation, and it's not defined at every possible x value. Okay? Those two simulations are what you guys wrote down. It's where the denominator is equal to 0, or if there's a negative underneath an even root. So, in other words, the most basic way I can say this is like this. If you don't have a fraction, or you don't have a square root or a fourth root, then the domain is all real numbers. But if you have a fraction, or if you have a square root or fourth root or any even root, then it's not all real numbers, and you have to do some algebra to figure out what it is. Okay? So any of the kind, all real numbers. These two, you got to do something different. Okay? So what we're going to do is we're going to look at 6 examples. We're going to look at 6 examples, and that's going to be it. Okay? That's going to be it for this page and it for the notes, to make sure you guys are okay with finding the domain algebraically. Okay? Got to find the domain algebraically. So let's look at A together. Look at A together. We have f of x equals 2 plus x divided by x squared minus 7x. Right here off gate, we have a fraction. More specifically, we have like an equation in the denominator. Okay? We have an equation in the denominator. We know that the denominator cannot equal 0. If we do, it's undefined. Okay? So in order to figure out what the domain is for this particular function, you set the denominator equal to 0. Okay? You set the denominator equal to 0. And you solve. Does anybody remember how to solve these types of functions? Whenever you see a squared in the exponent, what does that mean? But there's another x involved, so then what does that mean? You can't divide by x. It's a quadratic function. Can't add it. We could do that. That'd be a long way. Y'all remember how to solve a quadratic? The x. What's that called? Y'all remember the x a long time ago? Factoring. Y'all remember how to factor? I don't know. Maybe a little rusty. Okay, and this is exactly why this is hard for students. Y'all remember some of the old stuff, okay? So we got to factor. The first thing you always look for when you factor is the greatest common factor. What the terms have in common? Do they have anything in common? They have an x in common. So you want to factor out that x. Remember, factoring involves a parentheses. If I take an x out of x squared, what am I left with? And if I take an x out of a 7x, what am I left with? Okay? This is how you solve a quadratic. Anytime you have an x squared and an x involved in the same problem, you want to factor. GCF is the first thing you look for. At this point, you set both of your factors equal to 0. That's x equals 0, and then that's x minus 7 equals 0. Now I need to solve. X equals 0 is already solved for, isn't it? Okay. What about the second one? So x is equal to 7. So at this point, we're pretty much almost done. We just actually have to write what the domain is. Okay? Now, 0 and 7 are the two numbers that make, and it won't always be 2, sometimes it might be 1, sometimes it might be 3, just depends on what's in the denominator. But 0 and 7 are the two numbers in this case that make the denominator 0. So we want to include every other number except 0 and 7. So every other number except 0 and 7 are part of our domain. The easiest way, in my opinion, to write this is in set notation. Because once you've gotten to this point, all you have to do is write it out. So let me see. Are these all attached together? So how do I write this in set notation? Well, I write the set of x values, because I'm talking about my domain, such that x does not equal 0 and x does not equal 7. And then, of course, x is an element of all those numbers. And that is the domain for that first function. By writing this, we're basically saying that we're including all real numbers except 0 and 7, because that's what's part of the domain. Everything else but 0 and 7, the two values that we found when we set the denominator equal to 0. Everybody catch that? Sure. That was that first stipulation. Okay? So far, so good? Let's look at B. We got g of t equals the square root of t minus 5. We have a square root. What numbers cannot be underneath the denominator? Underneath the radical? Negative numbers. So that means that whatever's underneath your radical has to be greater than or equal to 0. Because 0 is not a negative number. You can take the square root of 0 and get a number. And you can take the square root of any positive number. So that's why you always set it greater than or equal to 0. How do I solve this? Add 5. So now I have t is greater than 5. So the domain of this function are all your values that are greater than or equal to 5. And again, in my opinion, that notation is easier because all I have to do now is add the goods. Okay? The set of t values such that what I just solved for, t is an element of what type of numbers? All the numbers. Now you are more than welcome to write this in interval notation. Either of these. You are more than welcome. Unless the directions say otherwise. What's the direction? And now you put line. It doesn't say. So you can do whichever, okay? Now B is a lot easier to write in interval notation than A was. Because A, you basically have to include everything but 0 and 7, which means you got to go from negative infinity to 0, 0 to 7, and 7 to infinity. That's a lot. When I can just pretty much write that and put some slashes through it. That's my thing. Are we okay? If you look at C, it has both of them together, right? We got a fraction, and on top of that, we have a radical in the denominator. So, not only can the denominator not equal what number? It cannot equal 0, but on top of that, the denominator cannot be a what number? A negative number. So how do you solve this one? You set the denominator, or the part that's underneath the radical in the denominator, greater than 0. Here we go. So, to solve this, we're going to still treat it kind of like an equation, right? We're going to add the 9 over, just like before. And we're going to take the square root of both sides. Not just like before, I mean like how you would any other like type of equation. Now remember, when you take the square root of both sides, you have to remember what? You got to remember plus or minus. But it's the inequality that causes the issue. You can't have x is greater than positive 3 and then x is greater than negative 3. It doesn't match. That's not a true statement. So basically what you're looking at is like this. your number line, your old school number line, you basically have -3 and +3. Where did I get these numbers? Right here, when I solved it. Basically, the numbers that will make the denominator not equal to 0 and also not be a negative number underneath the radical are either lying in this region that is less than -3, in this region that's in between -3 and 3, or in this region that is greater than 3. In order to figure out what it is, we have to check. We have to see which regions actually work. Okay, we have to actually see which regions work. And that's why I said this one's a doozy. Okay, this one's a doozy. But it only occurs when you have a square root in the denominator. It's the only time you're going to have to do this. Okay? So how do you figure out which one of these areas is actually the answer, was actually the domain? Well, what's the number that's less than -3? -4. Okay? When I plug in -4, let's say, plug it back in here. What's -4 squared? 16. What is 16 minus 9? 7. Is that greater than 0? So because when I plug in a value that's less than -3 and it actually ends up being greater than 0, that means that all the numbers that are less than -3, not just -4, it would work for -5, -6, -100. All of those values are part of the domain. So we use -4 as a test point. We plugged it back into the original restriction that we had, and because it was greater than 0, then that meant that any number that's less than -3 will be greater than 0. Okay? Let's test the middle region. What's in between -3 and 3? 2. What's an easier number? 0. 0 is always easier. Still, plug it back into the restriction that we created. 0 squared is -9. Is -9 greater than 0? No. So then that means that any number that lies in between -3 and 3 is not going to work. It's going to either give you a negative under the radical, or it's going to give you 0 in the denominator. What's the number greater than 3? 4. What's 4 squared? -9. Is that greater than 0? Yes. So, your domain, the values that actually make this function defined, are all your values less than -3 and all your values greater than 3. And that, my dear students, is the domain of C. Okay? To represent this, you want to do set or interval? I'll let you choose. Okay, if you want to do set, then I need the set of x values such that, so that includes the goods. I need to represent all the values that are less than -3. How do I write that as an inequality? Less than -3. How do I represent all the values that are greater than 3? And of course, x is an element of all real numbers. Let's look at D. What do we have here? Do we have a radical? Just the denominator, which means that when it's the fraction, when it's the denominator, we have to do what? Set it equal to 0. And then we're going to have to solve this. Then the domain will be everything but whatever this is. Okay? The quadratic, good old quadratic. Is there a GCS? Something in common between all three terms? No. So it's when you go to the old school 2 parentheses. and you ask yourself, what two numbers multiply to give you, oh, okay, those are the two numbers. But what two numbers are multiply to give me what number? The C, the 12, and add together to give me the B, the 7. And those two numbers are 3 and 4. Then I have to solve this. Solve for each. X equals what? And x equals -4. Which means the domain cannot equal -3 and -4. Then you just add in the good. It'll look just like the first one. So y'all gonna be saying the good. Next class. Okay. Yeah. When it's just the denominator, it's a lot easier. When it's just the radical, it's a lot easier. It's bad when it's got both in the same problem. Then you're like, oh my goodness, what in the world? When I look at E, I have a, which means got to be greater than or equal. Okay? So maybe a couple of notes to add in. When it's just the radical, it's greater than or equal to 0. When it's the denominator, you set that equal to 0. When it's the radical under the denominator, greater than 0, you know, a couple of things to help you keep it clear. Okay? When we look at this one, what do you see? Is it like B? It's not like B because it has the squared with the inequality, which means we're going to have to do the line again. Okay? Which means we're going to have to do the line again. Let's figure out what two numbers are on our line. I'm pretty sure you guys can kind of see already what numbers are going to be on our line. Add 4. Take the square root. What numbers are going to be on our line? Plus or minus 2. There's always positive 2 and negative 2. Plus or minus. So again, we have to test out the regions. Which ones actually work? Which ones actually work? We need to pick a number that's less than -3. What's the number less than -3? Ooh. I mean, -2. -3. Sorry, I'm jumping the gun. I apologize. Where do I plug that -3 into to check? What's -3 squared? -4. Is that greater than or equal to 0? What's the number in between? 0. 0 squared minus 4 is? Does it work? What's the number bigger than 2? When I plug in 3, does it work? Yes. There is a situation where it'll be the one in the middle, but I can't, off the top of my head, I cannot think of which one it is. Okay. All right. Now, this one, unlike C, because it was actually equal to the plus or minus, this one is going to include the -2 and the positive 2. Okay? So unlike C, where it was just greater than 0, since this is greater than or equal to, it is going to include those values. Okay? So how do I represent this one over here on the left? How do I represent that as inequality? Less less than or equal to negative 2. What about the one on the right? And then, of course, you got to include the goods. So we have 8x divided by the square root of 2x plus 6. Which one of these stipulations is it? Is it 1, 2, or 3? 1. Because we have a radical in the denominator, which means that whatever is underneath the radical, we have to set it greater than 0. Okay? And so, how do I solve for x? Minus 6 to both sides. Just like when we were solving inequalities on the homework the other night, similar thing. So we subtract 6 to get this, and then what do? Divide by 2. Do I have to worry about a plus or minus here? No. There's no squared involved. And because there's no squared involved, no need to worry about doing this whole gizmo over here. We only got that one solution. It's all the values that are going to be greater than 3. So, add in the good. And we're done.